National income dynamics can also be founded on money market, just like we did in case of capital market equilibrium. Let us see how we can do it. As we know that money market is elaborated with the help of demand for money and supply for money, and as we see that in money market, the government sets the money supply as a percentage of the national income from the previous period. So this is the national income in the previous period. A certain proportion of it is being allocated as the money supply. And when we talk about the demand, the transaction demand for money depends on the current income. That is, the current income determines the current demand for money. These are the parametric restrictions that both beta and S, they are in between 0 and 1. This is alpha, which is a positive thing. It means that we have a positive slope in case of demand function. A positive intercept in case of demand function. It is the intercept. This alpha is the intercept. Now what we need to do is to develop an aggregate demand income time path and see if the equilibrium on the money market exists and it remains or goes away from the equilibrium level of national income. That is, the time path is stable or unstable, and what is the pattern of the oscillation in it. We know that S is the proportion of previous year's income that is converted into supply of money in the current time period. So MS, its value is substituted, and MD, its value is substituted in the money market equilibrium. And in this we can rearrange and we can get this form, which is close to the first order difference equation standard form. However, this beta is not okay because we want 1 instead of any other value as a coefficient of the first variable. So we divide it throughout by beta, due to which we got this expression, out of which this is the value of A and this is the value of C. A should not be equal to 1 if we are to apply the first formula. For that, what we do is we assume that beta is less than 1, because if they are equal, that is beta and S, then it will turn equal to 1 minus 1. This is something we do not want. That is why we say that beta is less than the small s, that is MP. That is the ratio of the previous year's income that is brought as money supply in the equation. So now assuming that beta is not equal to S, rather it is less than S, we can use this formula. This is the formula A, beta is less than S, and when we take its ratio we get something not equal to minus 1 because they are not equal to each other. We can extract the value of A as we have done before, write the value of C as we have extracted it before, and then we can write all other values and then we can substitute in this formula. As you can see, this is the value of B, which is equal to minus A. This is the value which is YP, actually the solution, the time path, the equilibrium value of the time path, and this is the value of C, this is the value of A. So now we are solving it. We can solve it by using the simple algebra. Here some symbols are used that we can solve using algebra, and a little bit of cancellation will also happen, due to which we will get this time path, which is the definite version, because we don't have A here, rather we have initial condition and other constants. This is the value of the particular integral, the equilibrium part. This is the deviation path or complementary path, complementary part of the time path. So this is exponential expression. This is S over beta, upon which the dynamic stability of the equilibrium will depend. So now we can say this is the time path we developed. This is the definite time path of this difference equation that we extracted from the money market equilibrium equality, that is MS and is equal to MD. And now we will consider this exponential part to determine the dynamic stability and the pattern of the time path. So we can see that we are assuming that beta is less than 1 S. This means that the ratio will be greater than 1 in its absolute terms. So when it is greater than 1, this is actually the value of small b. It means that we will have a divergent case. Whereas the ratio of these two constants, that is s and b, both of them are positive values, so their ratio is a non-negative value, which means that we have a non-oscillatory time path. And this is the summary of the whole thing, that we have a divergent case which, because beta is less than s and the absolute value of s over beta will be greater than 1, so we will have a divergent time path. So this was the development of the symbolic representation for this case, where we developed a time path for the national income, which was based on the first formula of the first order difference equations. And the first order difference equation in this case was developed by depending on the equilibrium in the money market, which is ms is equal to md. And this was the requirement from this economic application that we just did, that we observed the income dynamics, and the foundation was the money market in it, and we used the difference equations to solve this. Thank you.